Hello everyone. Now I am representing electromagnetic field theory by Markus Zahn. This is problem number 10C. In this question, it is given that we have to find the magnetic field at the center of a regular polygon of n side. That this is our regular polygon of side n. And we have to find the magnetic field at the point P or center of this polygon, and it is given that this distance is equal to A. Again, this distance is equal to A. So if you draw a perpendicular here, then let this distance is equal to R, and the side, each side of this polygon is equal to L. So this much distance will be equal to L divided by 2. Again, this distance will be equal to L by 2. So from this diagram, we can write R square equal to A square minus L divided by 2 L square equal to A square cos square theta. But this angle theta is equal to pi divided by n. Therefore, we can write R square equal to A square minus L divided by 2 square equal to A square cos square pi divided by n. So from this equation, again we can write L divided by 2 square equal to A square minus A square cos square pi divided by n. So L divided by 2 square will be equal to A square into 1 minus cos square pi divided by n. So L divided by 2 square will be equal to A square sin square pi by n, or L divided by 2 will be equal to A sin pi divided by n. Now magnetic field due to a straight conductor is given as B equal to mu naught I, and half length of the side, its half length is equal to L divided by 2 divided by 2 pi R multiplied by L divided by 2 square plus R square. Now this magnetic field becomes B equal to mu naught I, and the value of L divided by 2 is equal to A sin pi upon n, and value of R is equal to A cos pi upon n, and its power is equal to half. Now as we are seeing, L divided by 2 equal to A sin pi by n, and R equal to A cos pi by n. So A square sin square pi by n plus A square cos square pi by n will be equal to 1. Therefore, our net magnetic field at the center of the polygon will be equal to this A and A will get cancelled. So after cancellation of this term, we can write, and there is again a. So after cancellation this term, we can write our net magnetic field B will be equal to mu naught I divided by 2 pi a into tan pi divided by n. This is our required magnetic field. We can solve this question in another way also. For that method, we'll use this formula B. Now this is the magnetic field for just for one side. If now this polygon, total polygon has n sides, so its net magnetic field B net will be equal to n times mu naught I divided by 2 pi a tan pi by n. For as a second method, we can write the magnetic field produced by one side is equal to B equal to mu naught divided by 4 pi I divided by R into sin theta plus sin theta, that is equal to 2 sin theta, and value of theta is mentioned here as pi divided by n. So its magnetic field B will be equal to mu naught divided by 4 pi I upon, now value of R is equal to a cos pi by n, and it is multiplied by 2 sin pi by n. Now this 2 and this 4 will get cancelled, therefore we can write its magnetic field B will be equal to mu naught I divided by 2 pi a into tan pi divided by n. Now this magnetic field is produced due to one sides of this regular polygon. If there are n sides of this polygon, then its net magnetic field B net will be equal to n mu naught I divided by 2 pi a tan pi divided by n. So this is our required magnetic field produced at the point P or center of the polygon.